Welcome back, everyone, to Switch Solves ISL with another problem that's actually from the IML. So, there's 3 circles, which is, I guess, the thing that can happen. So we're going to start by letting O be some point. And then I need, like, a circle. Well, we'll just do this, alright. Omega is circle O1. Ta-da! Okay, and then we poke a point here, and we poke a point here. Okay, so there is a circle centered. So the second circle and the first circle don't behave the same. There's first of all a circle centered at some point on line ON. So let's just draw a random point and move it around. Yo, S. All right, and then omega 2 is circle SN, and then I need to pick a point on. Oh, actually. Oh, this is where I have second intersections, and they're not symmetric. Oh, Jesus. Alright, we'll just roll with it. Okay, let me call this Q or something. I think that might fit better. We'll just put like P somewhere here. So this is the center of the other circle. Okay, so then there's another circle here. This is omega 1. And then you take, what the heck is this setup? A and B, and there's like a point. Did I misdraw the picture already? Yeah. My bad. Those are not A and B. Those are like X and Y. Oh god. Why does this problem have so many ambiguous intersections? That's like nightmare fuel. Okay, so I am now much more scared of this problem than I was 5 minutes ago. Because ambiguous intersections are bad signs. They are anyways, okay, so A and B, that's the image of the multiview, right? So, I don't know. Are they going to be tangent at P? Is that just what's going to happen? Well, one way to find out. Alright, so you draw those, and then apparently this is tangent. Definitely at P. I was like, I don't know what else the tangency point's gonna be. Oh wait, what the heck? Okay, wait. I think I misread the problem then. Okay, touch the internally, M and N. The center of omega 2. Oh, freaking! I got this. No, I got them flipped. No. No. All right. Change of plan. P is a point on line OM. Oh lord. And then Q. Q can be. Okay, that's actually less scary though. Because before it felt like the knot was going the wrong way anyways. I think in this version it's more. It's more like the second circle only comes in at the very end, which is good for us because it's annoying. Okay, so it's not tangent at P anymore though, but that's not a big deal. So okay, so A and B are definitely just points on a vertical axis, right? So I'm taking the homothency of the radical axis perpendicular to PQ, and that should be like this point. Yeah, so that should all just, okay, so we're gonna draw the radical axis PQ. And this point will be a special, let's call it T. Why is there radical axis though? So the power of A and B is equal. So I pull this one in. It's weird because I feel like the point Q can vary a lot, right? But the tangency point doesn't... Oh no, the tangency point does change. But it feels like this Q is like just very... Like you can just spin this and then like part of the figure is standing still. I almost wonder... Okay, also, I guess I should draw MN, right? And like... And why is the tangent here? What can I do with that? Why is that there? Okay, well... Okay, so Q is just the arc midpoint actually then, right? Of... Yeah, I feel like the reference triangle actually wants to be triangle MCD. So you have a triangle MCD, Q is the arc midpoint, T is just the midpoint of CD, period. And you want there to be a circle. Oh, come on, this has to be easy. TC equals TT, I agree. But yeah, I feel like I have the wrong reference triangle. I want triangle MSCD to be my reference. Not what the way that it's given the problem. So I think the way we think about this is triangle MCD is given, and... Or maybe triangle MAB, I don't care. But MCD is given, and then I draw a circle, there's a radical... I guess the radical axis is here so that like I can draw the radical center. Because points A and B don't seem like they really matter. Okay, so we're gonna let R be the intersection of line AB with the common tangent line. I guess it's... Ta-da! Radical axis. Yeah! Okay. Okay, what is my play here? Triangle, midpoint, I want it to be tangent. The circle is literally centered here. Hang on, that's very confusing actually. What is this? Do I want MAB as the reference triangle then? Maybe MAB is a... no, I feel like I want the purple as the reference. So triangle MCD is given. I pick a point Q. The point Q is the arc midpoint. That's just true. And the construction is I pick a circle, draw the other circle that's tangent here. So we don't know what passes through T yet. That feels so crappy, actually. Dum-de-dum. Yeah, so I think basically the way to think about it is Q is the circumcenter of Y, X, N, and we want to show T is also on the circle. This is really awkward. Do I care about AB anymore? Can I just eat this whole radical axis? I'm just gonna eat this whole thing. I don't feel like it matters. It's garbage points. So set up triangle. Wait, if I do that, yeah. Triangle. Arc midpoint. I feel like I did something wrong. Hang on, now I'm confused. Wait, so isn't that obviously false then? Wait, what? No, somehow the radius is determined, but I don't see how. Like the homotopy factor from the purple MCD to the black circle is somehow fixed, but why? What thing is holding it in place? I definitely jinxed it today. It's just not easy to be. Oh, I'm confusing tangent at like a specific point with just broad tangent broadly speaking. I really want this setup to be a little more natural though. Death Star. I feel ya. You're telling me NT goes to the upper arc midpoint. Or similar. So assuming they are doubly tangent at n, what I want to show is, so basically it's assume this tangent, show qt equals qn, where q is the center, or the arc midpoint here. Weird. I'm a little disoriented by this setup. Aren't there 4 degrees of freedom? I think the problem has 3. I think you pick... Am I crazy? If you pick a big circle, pick MN, and then pick Q. Right, but picking the circle is... There's a rotation degree of freedom you're dropping. Like, if a triangle has 3 degrees of freedom, then it's the same as you fix a circle for nothing, and then you pick 3 points on it. I think the same thing is true. If you fix the circle, then it's like pick M, pick N, pick Q. So it's 3 points once the entire circle is chosen. The reason it feels weird is because there's a rotation, normally, that we also mod out by. So a triangle has 3 degrees of freedom, and I think by the same token, so does this fixture. It's like M, N, Q. You pick 3 points on one-dimensional curves. Yeah, it tripped me up as well when I was looking at it. I was like, really? This is only 3? But I think it's 3. I hate everything. I thought this would be quick because it was in 1999 Geo. Oh, that's what I get. Okay. But what is... I wonder if I actually should have gotten rid of A and B. Maybe that's a mistake. Maybe I should be dropping the tangent at N instead. Like ignoring that tangent. Alright. Alright, we're gonna add in some arc midpoints. I don't think I can just like solve this problem by staring at it now. Okay, so intersect perpendicular line from O to line CD against the bisector line MQ. This one will be called X. Wait, did I already use X? Shoot. All the good point names are taken. W. So we're gonna take that multi that maps so that point exists. Meanwhile, L is the antipode, I guess, and we would like hiding this purple circle, I guess, maybe. Oh, I don't really want to hide the purple circle. I think you can determine it, it's just like very unnatural to do so. This picture sucks because I really think that it looks like Q passes through T. So I'm like, I keep confusing myself which things are known and which things aren't. Or yeah. Oh, this is annoying. Okay, so WL. That point might actually be pretty useful. Maybe. What is your definition of T right now? I have no idea. That's the problem. Yeah, this is GeoGebra, yeah. Can you hide segment CD? Oh, that's a good idea. How do I feel about that? I guess it makes sense because we're not doing anything with it. So what's the play now then, though? Like I have these. Okay, I have the circle picture. Can I phrase this in a way that doesn't depend? C and D are here. Q is some arc midpoint. So here's the southern pole. Here's the northern pole. And then I like. I don't know what I'm doing. There are a lot of known angles though. I wish the lines were a little farther apart because I can't really read this. You're actually right. C and D don't seem like they should be that important somehow. Right? Like, you have an arc midpoint, but... I mean, it's basically like there's a circle, and you let T be the point here, and you say, I want CTD collinear. So maybe we can make CTD solid and just say somehow we want to get, like, CTD collinear. Because you still get the, you still get this line and this line that we just drew, these new lines. And then somehow we want to worry about C and D last, because they are not actually that great, somehow. So T is the northern pole on here, W is the southern pole on here, Q is the center of the circle, So there's like 7 billion equal angles. Perp. And that probably means we need A and B back though. Right? That probably means we need A and B back. I was trying to kill it. So we want to show CD as tangent. QC squared minus QN squared. CD squared. Wait, what? Oh, you want to do it by like a Python thing? I don't know if I like that much. What's the other? So these segments are the weird guys. I don't know what the heck they're doing. I almost want to be like, I want to show the homotopy factors like do something. Like this purple one. So there's like a homotopy at n that maps L to T, and there's a homotopy here that like sends something to something, A to C. And the question is like, under what conditions are those? What conditions do I need for them to have the same y coordinate in this picture? ABMN is harmonic. Wait, it is? I guess it is. Yeah, okay, no, that's true. It is harmonic. I didn't notice that earlier. What does that do? It tells you that when I pull this back here, it's also... Is it a good point to project through? You could project through... I don't know. L? CD? No. It's really awkward because the homotopes are at M and N, which are not like, do not have y coordinates at the, damn it. But I also feel like I haven't done my angle tracing yet. Like, there's gotta be a bunch, there have to be like a million like equal angles here that I haven't looked at yet, right? Like, I swear they are parallel, like, these two black lines are parallel, and then like there's two isosceles triangles, Bilgelian cyclic quads on the big circle, I guess. I think all of this is still really telling me I should draw a line at 9. Because in order for my angles to travel, I need that. So for example, angle LWM is equal to angle LNM, which is also equal to angle WMO. Maybe I do introduce this point. Where is this point? And why is it on the radical axis? What is this point? I can see why they're concurrent though. They're concurrent because ABMN is harmonic. So if I take the radical axis and just like the light green line, then projection to the kite will force this point here. So for harmonic reasons, there is a point here. Do I like that point? Is that a point I want to play with? CMN equals TMD. Wow, that is the most. I mean, not wrong. Hey. Is that actually what I'm supposed to do? If it is, I'm going to be very impressed. No way. This is a mixed to linear thing? Is this a mixed to linear problem? No, it's not. No. You're kidding me, right? No, I don't believe that. I don't think MN is the mixed to linear chord. Is it? I don't think it is. It's not on the right lines for that to be true. Oh, but it... Okay, so Mnqt is probably cyclic though, right? Yeah, I've done this angle chase. I think it's the same angle chase as in that Japan problem from a while back. Mnqt is cyclic, that much is true. Oh, that is a really involved way to get that is. Okay, so if that's cyclic, how does that help me with C and D? I wonder if... do I need this point? This is really roundabout though. Oh my gosh. I believe his claim, then frick, just intersect them, Jesus. See, they used up M and N, so I don't have midpoint names. Yeah, so MTMF is a thing. Because T is the northern point, so if you have something that's perpendicular. Wait, I feel like I'm running in a circle. What's going on? Isn't this how you... Hang on. I guess you can get rid of C and D that way now though, right? Can you? So if MTF were collinear, we should be okay? Because then you can take a multi-D that maps AFB to CD, and then CD intersect MF. Wait, why is that? Okay. God, this logic is so convoluted. Here's a tendency point. A billion things happened. If I can prove MTF are collinear, then when I take the homotopy, F will go to somewhere on there, and C and D. Yeah, okay. I think MTF collinear is enough, although it's going to be really obnoxious to write. So that's how I'm going to get rid of the C and D. Goal, show MTF collinear. Those points kind of sucked. I feel like I'm missing something pretty important or something, because this feels really roundabout. Especially relative to the time period this one was given. Okay, but I literally just said that, like, what? I just said that MQ, what circle was that? I forgot already. Yeah, MQT is cyclic. So I wanna, MTQ is equal to MNQ is like that. So I want to tie QTF somehow to that same angle. How can I do that? QTF is TF MOFN, I want to be cyclic, which it is. So that's it? Are we done? Is that it? Can I go home now? I really feel like I'm missing something. I don't believe this is like the expected solution, because this is both really long and really convoluted. Also, did I ever use like... I don't know if I ever used the dark green lines. Let me see. I don't think I ever used them, which is sad. Another attempt to use radical axis has been foiled. I don't think I used radical axis at all, which is... This is straight homotopy the whole way through. Okay, actually, I kind of use I use them very briefly to get MOFN cyclic. Can I get T cyclic faster if once I have that? I don't think I use E actually. So ostensibly, I should name this point something better, but I don't know what to name it. Thank you, XTDS, for the follow. I'll just call it U. The other point U can go do whatever it wants. Alright, so let me make sure I have this right in my head. This is actually a really long argument. So first it's show, okay, so MOEN is cyclic because they all lie in the circle with diameter OR, where R is the radical center. That is enough to get you that MTE are collinear, because now QTE is equal to TL, MEL is there, and MTQN is cyclic by a separate angle chasing argument, which also involves like some isosceles thingy. Actually, that doesn't involve very much. Just shoot. So then you get MTE cyclic, and so once you get MTE collinear, then you use homotopy and pray. So homotopy will map WAEB to QC something D. The something works out to have to be T. And that's a wrap. Okay, I don't know what the heck just happened, but that happened. Yeah, I think that's it. Yeah. And okay, now that I like don't have a bunch of unnecessary junk on the diagram, it feels a little more reasonable, but I still feel like I'm not seeing something. Like, I think what's going to happen is I'm going to look at the solutions on AOPS and then I will be like, oh, I'm stupid. But for now, let's write up what we have. Oh, alright, I forgot something important. I have to move the point label so I don't deal with it later. Okay. M A N Q is kind of screwed. Wait, why is my script not working now? What? Excuse me? I have no fucking clue. All right. Okay. Okay. Okay, so we can blow that diagram up a lot. That's very small. Okay, so this is going to be really convoluted, but I didn't... I don't have much choice. Okay, so definitions are let P and Q be the centers of omega 1 and omega 2. Let T be the... Let MQ, line MQ meet omega 1 at W. Okay, so PQ is perpendicular to AB, and let L be the antipode of W, and let T be the homothetic image of L. Under... Well, okay, we'll just say let T equals PQ cap and L. Wait, now I'm confused how to find anything. I think this is backwards. Meanwhile, let T be the intersection of segment PQ with omega 2. And let L be its homothetic image. Since PQ is perpendicular to AB, it follows LW is the diameter, is a diameter of omega. And then we let LW, LO be its center. So, okay. Alright, so that's the setup, which I'm like looking at this and being like, did I screw this up? Because this feels very strange and also like, I don't know. I just feel like if I like made a circular logic error, I probably wouldn't notice because it's. I think this part is fine so far. Okay, so claim MNTQ is cyclic. Proof directed angle TQM is equal to directed angle LWM is equal to LNM is equal to TNM. Alright, so that part is fine, and then claim oh frick. The midpoint of AB got left off the picture. Monkey patch. So OEMN is cyclic. And that's because by radical axis, the lines MM, NN, AB meet at a point R. Then OAMN is on circle with diameter OR. Claim MT are collinear because directed angle QTE is equal to directed angle TEL, directed angle TENEO. Wait. Shoot. I might have messed up. Oh crap! How did this go? Wait, which one? Which ones did I pass through? I needed OEMN. Shoot, I got nothing on T though. That's the problem. Frick. I think I ran in a circle. Crap. God, I got an English wrong. I want to do it from... I want NMT... Okay. We should be okay. So, we want NMT to eventually equal NME. So, NME is NOE. And NMT is TQN, which is the same. LON. Wait, why am I off by a factor of 2? What? NMT. What did I do? Wait, NOE is twice LON, right? So something's wrong. NMT. Wait, why are these off by a factor of 2? That's not supposed to happen, right? Oh, wait, I just NL. Oh no, it's fine. I'm looking at the wrong angle. All right, we're good. Jeez, scared the heck out of me. That should map W to a point on line. It should map E to a point on line ME, which is also on the line through Q, parallel on the, what is T? Line through Q, perpendicular to AB. That is 2.T. Hence TCD are collinear at the end. All right. Okay, so it's not actually that long, but I feel a little like, I still feel a little queasy about the whole thing. Alright, that's a wrap. Yeah, this was way harder than I thought it would be. Because I looked at the problem statement, I'm like, oh, this just looks really wimpy. And then, nope, nope. I think I realized that I was in for it once I started constructing the diagram, and there were like a billion like ambiguous intersections where it's like a line intersects a circle and you pick one of the 2 points. Whenever that happens, I just like say to myself like, oh, all right, here we go. Because those problems, there's something about them. I've never been able to formally explain like why these problems scare the heck out of me, but they scare the heck out of me. Oh well, yeah. In the end, we only used the we didn't use the fact that these green lines met here. So it was like a bit of radical axis and everything else was angle chase symmetry. So it's like a good like elementary geo problem, but holy crap, that really threw me for a loop. This is a good problem. Will you try the IMO6? No. I'm not in the mood for an FE right now, sorry. Honestly, I didn't think this would take so long, so now I feel bad because I'm supposed to get to some of the other ones that got voted in, but it's done dirty. Alright, yeah, at least like we knew immediately where the tangency point was. Like it would be really scary if it was a problem where we couldn't identify the tangency point either. Invert. Okay, very cool. Curvilinear. Like okay, but like, all right. Everyone's just using inversion. Jesus Christ. Okay, now I don't feel bad at all. This. Inversion of A. Alright. Alright, all you kids with your fancy stuff. So. I don't do super inversions like this. Mo's over 10. I think this is much more than 10 Mo's. Yeah, famous last words. White space is a little funky. All right. Yeah, that feels like an IMO 5 geo. It's not a 3.6, but it's not a 1.4. So good job, IMO 1999. You should add it to EGMO. I like never want to touch the publishing is too hard.